Today's housing crisis is as severe as it is universal. In many countries, over 75% of the basic housing needs are unfulfilled each year. There is an urgent need for low-cost, energy-efficient, and environmentally sound building products. The Enviro Board housing system provides an innovative solution to this housing crisis. This is rice country, Sacramento Valley, California. Each year, about 500,000 acres of rice straw are planted, producing over 1 million tons of rice. California holds the second rank among states in the nation in acreage planted to rice. About 95% of California's rice is grown in the Sacramento Valley, where it is the most widely planted crop. After the rice has been harvested, the straw has traditionally been burned, causing numerous health and visibility problems to the local population. What was once considered agricultural waste, merely burned up, can now be used to build superior building structures. Enviro Board Corporation has come here to the Valley to demonstrate an alternative solution to burning California's rice straw. Our new 20,000 square foot plant and model home located in Colusa has been completely built with fused fiberboard. The Enviro Board building system is one of the most unique building concepts in the world today. Almost any kind of plant fiber, from rice straw to wheat straw, sugarcane, or elephant grass, can be transformed into low-cost, superior building panels. Now let's take a short trip to our research and development facility in Eugene, Oregon.
What we have here is the Enviro Board 4th generation fiber extrusion mill. As you can see here, we're loading 14 to 1,500 pound large, big bale rice bales from Northern California. The bales are then debaled. In this process right here, as you can see, we have 3 rotors. Moving along through here, it debales the straw very quickly. It drops the straw to a series of straw walkers, which are behind this enclosure right here. The straw walkers then sift out a lot of the powdery fines and some of the smaller fibers. It then takes it and removes it into an auger. The auger then removes it to what we have as a cyclone. As you can see, it's been placed outside the building, so the residue of the straw, which is being compressed on the inside, is slowly taken out through a vacuum system and put through the cyclone here, and any residue is then deposited in the lower chamber. Once the straw has been taken from the straw walkers, it traverses very carefully up to another series of rotors, which are called our shredder rotors. The shredder rotors complete the cycle of taking the straw and further reducing it to a smaller fiber and moving it along to a conveyor belt. The conveyor belt comes along right here to where we have a skimmer. The skimmer moves the straw, pushes it down to make it almost like a carpet, and it moves up the conveyor belt all the way up to the very, very top where we have a picker. Now the picker takes the straw and deposits it down the throat into a series of 2 apparatus. One is a pre-packer and the other is a packer, where the straw is compressed very tightly before it enters our ram chamber. The ram is then compressed in at about 35,000 pounds of pressure and starting to make board. And it presses it into what we have as our first primary platen, which is behind here, which is heated up to about 400 degrees, top and bottom. These are chrome platens. The board is being formed and is continuing to be pushed 5/8 to about 3/4 of an inch per stroke. We're running about 60 strokes per minute. As it gets through the bluer platen, the board now is completely a membrane, covered with paper, sealed nicely. We've got a 32-inch wide panel that's 2 inches thick. Our puller then grabs the board, which is under an air compression system, and starts to pull the board through. As it pulls the board through, we can regulate the density of the fiber. We can make it more dense, we can make it less dense, and it continues to roll down to our fine cutoff saw. And the cutoff saw takes one pass and cuts the board. The board is quickly rolled out, all automatic, onto an outfeed table. And the outfeed table moves with a chain drive the board away, so we can continue to have the next board ready for this whole process. And it continues to repeat the cycle over and over again.